By popular demand, this week's streaming audio is all about schemas and schema evolution. Because I've heard a lot of people asking for guidance on how you manage data long term as the shape of it changes, as the schema of your data evolves. So in this podcast, we've brought in one of our experts, someone with a lot of experience in the field, to go through it all, from the simple early stuff like why you want to define a schema and what format you should choose for it, and should you choose the same format for the whole company, all the way up to the really juicy problems like once you've got a topic with years worth of data in it, how do you migrate that schema without downtime? The expert we have in question is Abraham Leal. He's this week's guest, and he's one of our customer success technical architects. And he spends most of his working time diagnosing schema problems and solving them. And he's picked up some interesting ideas from the best developers out there too. So we've done our best to take you through the whole process, from the problems you'll face on day 1 to the problems you'll face on day 5. This podcast, as ever, is brought to you by Confluent Developer, and I'll tell you more about that at the end. But for now, I'm your host, Chris Jenkins. This is Streaming Audio. Let's get into it. Joining me today on Streaming Audio is Abraham Leal. Abraham, how are you doing?
Doing good, Chris. How are you doing?
I'm very well. Where are you coming in from in the world?
I am out of Austin, Texas. So where the most recent current happened, it was right local to me. So yeah.
Oh, very convenient, but less glamorous. Mm-hmm. You don't get to travel to a conference.
That's right. But you know what? I enjoyed it just the
same. Yeah. I probably get the same deal when I go to Kafka Summit London next year. It's basically on my doorstep.
There you go.
But we're not here to talk about conferences. We're here to talk about data contracts. So, data contracts, I think they're basically the same idea as schemas and types. We have a few different words for them in our industry, right? They're like being explicit about the shape of your data.
That's right. I think that data contracts really encapsulates the whole concept of making sure that the data that your organization is producing from all its operations is ensuring that you can have that data be reusable across the various business units that your organization has, right? So before we would think in terms of, let's define my schema, let's define my simple object for my program. Data contracts to me really encapsulates the whole flow. Hey, I need to define a schema, and I need to define how I'm going to make that available and how this data will eventually transperse my system, right? Okay. So it is maybe kind of like an encompassing subject of the things that we already have. So the values being possible, we've given it a formal name.
Right, yeah. So you're also, as well as like the enforcement idea, you're talking about broadcasting the shapes to other places. Yeah. Okay, so let's start from the very beginning of this story. I can imagine there are people using Kafka who have a JSON blob and they just stick it on a topic and they're done. And if someone wants to reuse that data, they're just going to have to have a look at the fields in the JSON object. Right. Why is that not? I mean, it's a fine first step, but why would you push people to a second step?
Yeah, no. So that is a normal, most common way to get started with Kafka. In fact, if you go to the Confluent Cloud UI and you try to produce data from there, it'll go as a JSON blob that is represented as a string in Kafka, right? It is the easiest way to understand what's going on. But it is definitely not either the most efficient or the preferred way that an organization will want to do things for multiple reasons. And I like to do things in threes. So I'm just going to give you 3 reasons. And then if there are more, we'll encompass them later. I would say reason number 1 is that a JSON blob represented as a string is hugely inefficient for data transfer, right? It does not get encoded into more efficient binary formats, such as other kind of like schema-full languages. Not languages, but formats would do, right? So it is a bigger payload that contains more repeated data that is not essentially needed and is sent over the network. So it's more expensive, because it's less efficient, right? Number two is, well, now you have this data that you have sent in, and there is no real control of what kind of data will follow, right? So from one message to the other, the JSON blob could change in 1,000 different ways, right? Like you have 5 field defines in one, there could be 10 in the other, et cetera, et cetera.
Yeah.
So, and that's really where data contracts kind of come in, right? And like being able to enforce certain data to be part of a pipeline. And JSON blobs, they do not. There's kind of like a JSON schema format that is out there that you can do with actual JSON, but it's not what the normal regular Kafka user will use whenever there's a blob, right? Normally they just send it as a kind of a string that will then be mapped into an object on the other end of the application. So it is inefficient. It is not very governable, right? Because there is no real contract around it. And three is just simply not the preferred data format that the modern architectures have built upon. JSON is, and for the foreseeable future, seems to be the language of the web, right? It's, between websites and services that interact in the web, this seems to be the preferred format, and that's totally fine. However, when you're dealing with Kafka often deals with backends that are a bit removed from that front end. And the preferred formats in the backends have evolved to ensure high efficiency and data qualities. And that's just not something that JSON has done when it comes to regular blobs.
Yeah. Yeah, because efficiency is an important thing, but I think everybody that's dealt with lots of JSON has had this process where they do, they process 10,000 records from something, and there's always one field that's always a string, and then suddenly one day it's null or a number, and all your processing blows up. And the only way to know what shape the data actually has is to keep collecting more samples.
Right.
There's no. You kind of want someone to officially say the definitive shape of this data is X.
Yeah, and JSON has been around so much as the default format to communicate between the web that they've found ways around this type of problem, right? Like there's open API specification around describing what you can expect from an endpoint, and then there's kind of like schemas defined for that endpoint so that you can understand them more. And then with the advent of GraphQL, they can even be even more specific about what the output of a web service is going to be. But that's all in the front end, right? And it's kind of like auxiliary tooling to help you give some normalcy to the chaos, right? In the back end, we get to do even more fun things around, hey, what do we decide we want the data format to be, and what kind of controls do we want here, right?
Yeah. And this is where you get the other two popular options of Protobuf and Avro, right?
That's right.
What are the advantages of those then?
Yeah, so Avro and protocol buffers, kindly shortened to Protobuf, they are formats that were developed with the efficiency and speed in mind that you'd expect from microservices communication, right? So both of them are extremely good at serializing data in a binary format that is schemaless and allows only the most essential data to be transferred over the wire whenever you're doing either microservice to microservice communication or asynchronous communication to Kafka. Both of them are really, really good at transferring only the data that is needed and decoupling that schema from the actual transfer, so that the users, the actual developers of the microservice, they can handle the schema and interpretation of that data. because the only thing that they really care about is the actual contents.
Yeah, so this is the idea that if I write 1,000,000 records with a company name field in JSON, then I've written the word company name 1,000,000 times, right? And there's
There you
not
go.
really any point to
Yeah,
sending that over the network. Whereas
exactly. Yeah,
Avro and
it
Protobuf
would be
can
so
pull that
wasteful.
out to one place. Yeah.
Exactly. Yeah, it would be super wasteful to do that, and that's exactly what you get. To bring it back to JSON blobs, right? Like that's exactly what you get. Whereas with Avro and Protobuf, they found more creative ways to be efficient, right? And they come with other things more than just that efficient binary format, right? Like they come with great schema enforcement rules.
Hmm.
They come with great evolution rules, right? They allow you to be extremely explicit. Specifically, Protobuf allows you to be extremely explicit around data quality inside certain fields because it's so extensible. So the format is not only there to be efficient, it's also grown a lot of helpful things that in the backend are very useful to have.
Yeah. You missed out one of my
Mhm.
favorites, which is you can take one of the descriptions and use it to generate like class files for Java and Go and
That's
Haskell
right.
and all the different languages just from that one description, which is really cool.
Yeah, I did miss that one, and it's really one of the better ones, right? I guess comparing it back to the JSON blob, well, the JSON blob is a JSON blob, right? So like, it's not
Yeah.
really like you have to do anything in language, um, or if you want to do anything useful, you'd have to end up mapping it, right? I guess that is something that's really good here, where you can create kind of like plain objects in any language through Avro or Protobuf helper tools.
Mm.
And this can be interpreted, in .NET, Java, Go, whatnot. A JSON blob, you'd have to use something like a Jackson library to kind of like map it into an object
Yeah. Yeah.
and do anything useful with it.
Yeah. And then probably you're guessing about the shape of the JSON blob for that mapping tool,
Hmm.
right? Yeah. Yeah. Yeah.
That's
It's one of
right.
those
Yeah,
advantages that gets larger the more different languages you have in your company, I think.
that's right. That's right.
Um, So that raises two questions, and you can pick which order to take them. We need to talk about the evolution features of those two formats and which one we should be using.
Yeah. The in in my opinion, protocol buffers is really kind of like taken ahead in the race whenever it comes to which format we should be using. If and let me hedge my position a little bit in saying
Okay.
that if you are a company that has been, you know, around for a while, you probably someone already at some point made a decision about this. And then
Yeah.
most likely, most of the company has adopted this standard. Like at some point, someone said, hey, we're just going to use a bunch of JSON objects. We're going to have like an object repository. And if you want to, interpret something, just go and fetch it from there. Or someone said, hey, we have a bunch of Avro definitions, just go fetch it. If someone has done this and your company is 90% already adopted Avro as the spec for your data transfer encoding, you should go with that. You should not you should not just go wild and utilize whatever you think is like the cooler, newer tool. Because even more important than like a tech problem, this is really a people problem whenever you're talking
Yeah.
about data, right? Because data quality really comes into play around, well, in the end, it's all just us coding this, microservices.
Yeah.
It ends up being a people problem. So if you have a standard, go with the standard. Do not try to push your whole organization to adopt Protobuf,
Yeah.
right?
Because there's huge value to just the agreement, the company-wide agreement, right? And you wouldn't throw
One
that
hundred
away.
percent,
Yeah. Yeah.
exactly. And
However,
it's
if you're in
agreement
a
from all
greenfield
sides.
project,
Yeah, yeah. If you're in a greenfield project, I'll go with Protobuf. 100 times out of 100.
convince me because I'm more of an Avro user myself. So sell me on it.
Yeah, yeah, no, for sure. So Protobuf is a more recent project, so they've been able to incorporate a lot of things that the Avro project they did not get to, right? They have very, very nice evolutionary concepts around like order of fields, where Avro, it matters how you evolve around order of fields, and
Okay.
Protobuf fields are kind of ID'd, right? They also have really good extensibility of the protocol itself. So you can do not only schema references in a very like natural way, I would say, a more natural way than you would do them in Avro. They're also possible in Avro. I'm not saying they're not. It's just more simple to understand. The extensibility also allows for data quality rules to be implemented in the protocol whenever you're defining the schemas.
Give me some
So there's a lot of
examples.
extensibility. Yeah. For example, let's say that you define a field that it's a credit card field, right?
Right.
Well, you could say I want my credit card field to be a string, right? You wouldn't make it an integer because normally credit cards have dashes. Though I guess
Yeah.
if you don't care about dashes, maybe you make it like a long int. I don't know.
Yeah.
But you can also say, if you define a string, you can say, well, my string, I expect, 4 sets of 4 numbers that are separated by a dash, right?
Right. Yeah.
And you can make that enforceable as you encode and decode the data from the serialization format, right?
Okay.
Whereas
Yeah.
in Avro, these type of enforcements, you kind of have to like augment either upstream or downstream, right? Whenever you're either producing the data or you're consuming and interpreting the data, you can augment from it, right? Where in protocol buffers, the extensibility it's there for you to use.
Yeah, because it relates to one of my pet peeves, which is strings are a terrible type in a way, because literally anything can go in a
Right.
string, right?
Exactly.
Is it the name of my user, or is it the complete works of Shakespeare? You need some way of
That's
narrowing
right.
that down.
Exactly.
Okay. And schema references you mentioned, what are they?
Yeah, so schema references, they're extremely useful concept around, let's say that you have a schema for who an individual is, right? So an individual will have a first name and a last name, right? You're pretty sure about that. But addresses, they might have multiple. Not only might they have multiple, they might have different sections of an address that you wouldn't normally want to put it as a string because, as you say, strings can be whatever you want. You like some structure around it. So schema references allow you to create complex objects for what you normally considered a field within an object, and then injecting them to create a more complex nested object. So in the example that we talked about, the individual, I could define the first name and the last name as strings, but then in addresses, I could define that as an array of an address, right?
Right, so you're defining
An
custom
address.
subtypes in a way.
Exactly. And the address itself will be a type that is a schema in itself that is nowhere defined within the schema that I'm defining for the individual, but it is rather defined somewhere else. And I can tell it, hey, go fetch it from here, right? Protobuf does this very nicely natively. Avro is okay at it. The schema registry, Confluent with schema registry makes it nicer for Avro, but yeah, they're very helpful not only for kind of like making more concise objects that are more easily human readable, but when it comes to evolution and long-term sustainability of this data, being able to evolve these separate entities individually is extremely powerful. It makes for a nicer story around the governance of your data.
Yeah, I can imagine that. By the time you've got 3 different objects that include an address, then you've got a
Right.
maintenance problem unless you can change it in one place, right?
Exactly.
Yeah.
So now an address is a single object for your whole organization, right? You got the payment service over here, and you got kind of the shipping service over here. They both won't have 2 different definitions of an address. They'll both have a single address definition that is centralized and then given to them.
Yeah. Okay. So let's say I'm convinced that I should write down my schema for the sake of everyone in the company. And I've chosen my schema format, which I'm choosing protocol buffers because you convinced me.
Awesome.
Off the record, I'll keep thinking about that. I'll do some more research. But on the record, I'm totally sold for the podcast. No, I'm kidding. I'm teasing you.
Yeah.
Right, but so that's all good. I start publishing my data. People generate their object types from my definition. Everything's great. Now I need to change my data.
Right.
Now, what support will my schema language of choice give me for changing the data format?
So the differences between the formats like in Avro and Protobuf and whatnot is less noticeable around what the evolution allows you to do, but rather how the evolution allows you to do it. So being backwards compatible or forwards compatible or fully compatible, right? There's like fundamental concepts here that are required in order to be considered backwards or forwards or full, right? So, for example, some fields, whenever you add them, have to be optional, or in certain times, if you want to remove a field, that field better be optional, right? Or if you want to add it, it better be required, right? It works differently for different compatibilities, right?
Okay.
Where it really differs between the formats is around how are these compatibility checks happening, right? Like locally, that allows me to be a little bit more liberal around adding fields or removing fields. Like, for example, I mentioned that one before, where Avro really, really cares where you add a field. It in fact takes order as a very big as a very big indicator of what a field is whenever interpretation comes around.
Oh,
right?
so would Avro stop me reordering the fields alphabetically if I just felt that way?
Exactly. That's right.
Okay.
Yeah. So that Avro does not like that. Whereas Protobuf, in its encoding format, it IDs fields by integers. Like if you ever define an Avro schema, you have to give it like a little number, and that's how it encodes it. And so order matters less in Protobuf, right?
Okay.
Where you can add and remove fields and define them differently.
Okay. So you referenced two terms. I think one of them might be familiar to people, the other might not. Forwards compatibility as well as backwards compatibility. Can we take us through that?
Yeah. So backwards compatibility, and I always get this mixed up because at some point they all start blending together. Backwards compatibility means that you can update your consumers first, and they will continue working as long as your producers produce with a older version of your schema.
Right.
And this kind of goes back to what is allowed, right? Like in backwards compatibility, you can add objects or add fields in an optional manner, right? In a manner where if the end object has it, like interprets it, but doesn't find it, it is okay for it. It says, well, this is an optional field anyways, right? So I don't really care. I can just continue going forward. The same is true for the reverse. Forwards compatibility says you can upgrade your producers first, and your consumers will be fine as long as certain rules are followed, right? So whenever you add a field in a forward compatible manner, the field is required, right? But since your consumers don't have the idea of what this new field that is required is, they don't really care. They'll just continue interpreting the data as they were before.
So I start writing, I decide it's important that we keep our product's country of origin. I can start writing country of origin into the new data, and since the consumers don't yet know or care about it, it doesn't matter.
Exactly.
Right, yeah.
Like they'll receive the encoded message, but then they'll interpret it fully and say, there's some extra data, screw it. I don't really care. Just
Yeah.
let's keep going,
Yeah.
right? So those are kind of like the two sides of the coin, and then there's full compatibility, which is the merging of both,
Right.
right? And nowadays, most companies will hear that and say, well, does that mean that I can just update in any manner, right? Like if I so choose to update my consumers first or producers, it doesn't matter, right? Like I'll just do it, right? And then
Yeah.
I'll answer them, that's exactly what it means. And then they're like, well, why would I ever go to backwards to forwards compatibility, right? This is like the best ever, right? Like it, and the answer is because full compatibility comes with caveats, right? Yes, with full compatibility, you can upgrade your consumers or your producers first. It really doesn't matter.
Yeah.
But once you enter the full compatibility round, basically nothing is guaranteed. You'd have kind of like a base structure of your initial schema, and then every evolution after that will have to be optional fields that are added or deleted. Um, and you will have no guarantees on whether a field even exists. At that point, you'd have to start doing like existence checks, right? Like, hey, I know my schema said that my field is here, but that field is optional. Let me actually check that it's not null, right?
Yeah. Yeah.
Mm-hmm.
And that feels a little bit like we're going back into the days when we were just guessing about the
Exactly.
structure. Right. Yeah.
Exactly. You're basically back at doing object mappers with JSON Blobs, right?
Yeah. Yeah. So,
Mm-hmm.
what would you recommend then? Should I get into a habit of upgrading my producers first and then only look at that direction of compatibility, or is there a habit that will help me here?
Um, when when people kind of like hear all of these options, the most common one is forwards compatible. Why? Because forwards compatibility does allow you to add fields that will be required in the future, right? So you can have
Right.
some strictness around your data, right?
Yeah.
It's like, okay, well, now I've decided that everybody must have a favorite color. Every individual from now on, I need to know their favorite color. It's required, and forwards compatibility allows you to do that, right? And that's very attractive for organizations.
Yeah.
And then, but then some organizations that are very careful and care a lot about compatibility, like just long term compatibility, um, they do full compatibility and kind of like eat the drawbacks of it.
Uh,
Um,
yeah. I guess
there's
if you're
some other. Mhm.
I guess if you're a company that really needs really long-term compatibility, you're going to fall into that hole eventually, right? That
Right, and
the version you need to be able to deal with every possible kind of version you've ever seen.
exactly, because think about it, right? Like you have this central nervous system in your company that is Kafka, and you have maybe 100 dev teams. Who knows, right? And they could have they could have integrations with Kafka, all from like the app in your phone to devices that like a TV that doesn't really get updated very often, right? So to
Yeah.
them, a change in the data contract is a huge deal, right?
Yeah.
Or even headphones, right? Like you don't really update headphones very often either. Uh, and that's where, hey, I really need to make sure that if I have a device that is 10 years old, I need to be able to interpret that regardless of where I am at 10 years from now.
Yeah.
Yeah.
Are you saying there's like a switch I can enable that will I say I want full compatibility and it makes guarantees to me and stops me doing things that will break that?
Um, I'm so full compatibility, depending on the checks, right? Like, and keep in mind, I'm saying a lot of this is keep in mind that schema registry is the one that's checking, right? Whenever these checks come around, I'm thinking schema registry. There's other solutions around, schema registries out there in the market. I'm
Hmm.
thinking schema registry. It If the compatibility guarantees are not there for whenever a new object comes into play for the data pipeline, a schema registry will ensure that producer gets shut down, because
Oh.
it will not follow the guarantees. That's right. Yeah.
Right. Okay. So let me follow this through naturally. I know what I was going to say before I say that. So this isn't a problem that's unique to Kafka, right? Any data format speaking between different systems will have this what happens when we change the data format problem. What we're really
Right.
trying to avoid here is the situation where I'm going to change the schema for my central database and everyone has to upgrade their software in that same maintenance window, or we're all going to have problems. Right? We're trying to
Right.
have a little bit of slippage between when the writer gets updated and when the readers have to get updated.
You got it. Yeah.
Yeah, that's what.
You got it 100%. It's
Cool.
it's a specific. So decoupling, it's all the rage nowadays, right? Like you
Yeah,
don't want one microservice to be dependent on another. I want full control and full liberty here, which is great. It's worked out great for a lot of companies. You just got to make sure that these compatibilities are there to make sure that as each microservice evolves, compatibility is maintained between them. Yeah.
yeah. No one's saying it comes for free. It just comes much cheaper than trying to get 100 departments to release on the same
Exactly.
day. Yeah.
Exactly.
Okay, so here I am. I'm thinking about full compatibility over time, and I've written in. I find that half of my data has a country of origin field for all my projects, and all the old stuff doesn't. Right. So I've got half
Hmm.
of my topic filled with this field exists, and the other with that field doesn't exist. I'd like to get to the point where I just have a single format for all the historical data. That
Right.
feels like something I'd like to have, but they're immutable, so I don't have a consistent thing. Can I what do I do about that situation where I have two different formats and I'd really like to unify it into one?
100%. So this is a very, very common scenario,
Yeah.
and I don't really talk much about what I do, but I used to be in professional services here at Confluent, and now I'm a success architect helping guide our customers um, architectures over a long period of time. And this is a problem that appears quite often, right? Like I want consistency within the data that I have.
Yeah.
It is most commonly solved today by what we call topic versioning, which really there's different ways of enforcing data contracts within kind of the Kafka ecosystem. But the most popular way is saying one schema that evolves over time per topic, right? This is the most common way.
Yeah.
Um, and topic versioning really goes to say, well, yes, one schema that evolves over time, but over time, I might say this schema is not enough anymore, right? I want a whole new schema that has other guarantees that my business needs today.
Yeah.
Um, and not only do I want new data to follow the schema, old data also needs to follow the schema. Even though this old data may not have like some fields, I like to convert this old data to the new format that I expect. So I think it worked nicely. So topic version is around the idea that where my topic before with evolution were great for me, I'm going to create a version 2 of this topic in this version 2 because Kafka's replayability features I am able to migrate all my data from topic 1 onto topic 2 with the same data format by creating kind of a caster between version 1 and version 2. I can do this in a multitude of ways. Probably the most common way today is through KSQL, right? It makes it
Yeah.
really easy to kind of like take data in old format and then spit it out a new one. And then the new topic will have the rule that only this format is accepted from now on. It is a strict format. If the field in previous data doesn't exist, I'll make something up, right? I'll put a null or I'll make an empty string. Doesn't matter, right? Like
Yeah.
I'll have my new format. It is way more strict, and now my new topic evolves from there. There's a bit kind of like a migration gap there where your producers would produce to the version 1 topic for a little bit, and then you would do a switch over between producers to the old topic and then producers to the version 2 of it.
So let me check I've got that step in my head. So I would I've got, I don't know, product version 1. I create a product version 2 topic.
Yeah.
I write maybe a KSQL job that rewrites all the old historical data into version 2.
Mm-hmm.
And I leave that job running so that anything new that gets written into version 1
Right.
automatically ends up on version 2. Then I'd
Right.
switch over all my consumers onto version 2, and they'd still be getting the stuff being bounced through from the producers. And then finally, I can move the producers over to start writing to topic 2.
You got it.
That's the
That's
process.
exactly the steps. Yeah.
Okay. What's the trade-offs of doing that? What does it cost me?
The number one trade-off here is literally the cost, right? You're basically taking data that you've already stored once. You have to store it all over again on the new version. You're probably going to be having to pay for some of the compute that is required, right, in order to translate all this data.
Yeah.
And then topic migrations, they're not a fun thing to do. Some companies, I work with a variety of them. Some of them they have it down, right? Like it's a science. They're like, it's not a big deal. We'll do it within an hour. And some companies are not as experienced in this type of kind of migrations, mini migrations, I guess. And they'll have an issue kind of like doing the right cutoffs and whatnot. So there is some complexity there. Where would it be nice to be able to tell Kafka to handle this migration for you? That'd be the best. But just the capability is not there yet. Yeah.
It's not yet automated. But
Yeah.
is there some fundamental difference between the companies that do it well and the companies that struggle, or is it just practice and habit?
There is I would, in my opinion, I think that the most fundamental difference for the companies that have it down is they have they have made data contracts kind of like a very important part of their data flows. I am a big believer of maintaining all of your schemas in a GitOps manner and then distributing them onto a schema registry or any other systems through that system, and that allows for very public ways on why something evolves, when something evolves, and when it's published and taken into production. And that helps people understand, okay, so now there's this that is in this topic, and then goes over into the other topic. So that is one big difference that I see. Schemas and data contracts, they're a central part of data flows within those
Right.
companies.
Yeah.
And then the other part is being very, and this is just with experience, being very used to understanding how consumers and producers in Kafka work, right? What is my consumer lag? How do I ensure that I make sure that whenever I migrate from consuming one topic to the other, I am not replaying events, I'm not redoing events that I already did, or I start at the very end from the previous topic onto the new one, right?
Yeah.
Understanding those concepts, it goes a long way so that people can say, well, yeah, I had consumer on version 1, and I'm just going to do a cutover, but I'm going to cut over on, this offset. And on the other side, I'll just start from the beginning. And I understand that I will maybe reconsume messages and reprocess them, but downstream I have an idempotent system, so it really doesn't matter.
Okay.
Or I will start at this offset, but on the new topic, I know exactly what offset that is. I've been able to look at it either through offset 4 times, and I have been able to configure my consumer group to start from that offset, right? That's another difference, right?
So like offset mapping from where you finished on topic 1 to where you're starting on topic 2.
Right.
That that seems tricky actually to figure out where that offset is. Do you have any tips for that?
100%. Yeah. So a lot of people, the number one way that they kind of like avoid all that trouble is to do the full switch over at once rather than doing the. We can call the migration story that we talked about kind of like a phased migration. Um, in
Yeah.
order to avoid all of this, you could just do it in kind of like a big bang release type of deal,
Yeah.
where you stop your producers first, you wait for all that data to be consumed on V1, and then to that KSQL transforms and produces onto B2. So now you know that the last message in B2 is the exact same last message than B1.
Yeah.
So you just
Okay.
tell your consumers start at the end and then move the producers onto B2. Yeah.
Okay. I see that as a strategy, but I feel like we've slipped back
Mm-hmm.
into making different departments coordinate.
Definitely. Yeah. So, there's the phase and, the advantages that comes with it. And then there's the big bang release where,
Yeah.
there is some coordination. But, you at least don't have to worry about the other stuff. Yeah.
Could I do something like in my process that's writing from version 1 to version 2, my perhaps KSQL process?
Right.
It occurs to me I could write the offsets from the old topic into the new record, and that would give me something I could read to make sure I was in the same place. Is
Yeah.
that a good
You
idea
could
or a
get
terrible
clever
one?
with it. I would say it's not a very good idea because it's offsets don't map very well between topics, especially whenever you're doing transformations, and even more whenever you're doing uh, exactly once processing, right? Markers start getting into it, transactions start getting into it, and
Okay.
knowing what offset was on the old topic for a message on the new one might be useful to kind of like, oh well, if I find that offset in the new one, um, then I'm golden, right? I know that I need to start from there, but then how do we even find it, right? Um, there's nothing that really tells us it will be near the offset in the old topic, right?
Yeah.
And you would probably have to inject it in something like headers that is not really indexable.
Yeah.
Yeah.
Okay. I feel like I want some more advice. Give me some more tips. I feel a bit lost on this particular point.
Yeah, no, for sure. There's also another phased approach where what you could do if you don't want to really couple both teams,
Mhm.
you could just uh, tell your consumer to consume from both topics at the same time and allow it to do interpretation from both topics, right?
Oh,
And
okay.
then you can stop and start your producer on the new topic with no issues, right? Because you know that there won't really be a double posting, right? Because as soon as you stop producing here, you start producing over here. So new data will go on to the new topic. Your consuming is consuming from both. Your consumer is consuming from both, anyways.
Yeah.
And then once the producer switches over, if you like, you can tell your producers to stop consuming from B1, and then you can just retire that topic.
Okay. Yeah. I like that. I like that. Um, I've
That is
just got one.
commonly the method that we suggest for DR, by the way. You do a regit subscription for two topics, one for your local and one for your remote.
Oh,
And then
okay.
whenever failover comes to happen, you're subscribed to both anyways, so you'll be
Oh,
fine.
okay. So you'd actually,
Yeah.
yeah. Okay, that's an interesting one.
Hmm.
Okay, so there was one other question I had for you buried in that. You mentioned upcasters and downcasters. So can you
Hmm.
define those for me?
Yeah, surely. So a lot of time, there is no real clear cutter way to allow for schema translation between one version and the other that weren't really evolved with the strict rules that forward and backwards and full compatibility set, right? Sometimes you have schema one that could technically be put on schema two, but it requires a little bit of logic, maybe some human elements, some human knowledge,
Yeah.
in order to put this schema onto the next one, right? And that is the concept of a schema, what I call schema casters, right? Where you can either upcast or downcast a schema to a version that is not really compatible from the rules that regular forward, backwards, or full compatibility gives you. Um, but it can be made compatible given certain human knowledge that is injected onto a service. This is a more complex way of doing things, right? This is not where you should go um, whenever you're starting with your data evolution story. You should always try to see if the regular rules can be applied to your data story so that you don't have to do anything custom. But, um, you know, there's a bunch of companies doing really interesting stuff out there.
Oh,
And this really comes from this company that I've worked with in the past, Core Financial.
core
Um, they
financial.
had they had a great talk around the work that they did around this area in Current, which I believe all those talks are online nowadays.
Oh, yeah, we'll put a link to that talk in the show notes.
Thank you. Yeah, and they're a great, very smart group of people, but they had a very particular problem around, hey, they need to store data for a very long period of time. Um, and then not only do they need to store it, they need to make sure that over that whole period of time, this data can evolve, in ways that, we couldn't even imagine, right? And
Yeah.
they work with regulatory bodies that don't really care about the rules of forward or backward or full compatibility.
Yeah.
They just say your
They slap
data
some
must
new rules
come.
on you.
Yeah,
Yeah.
exactly, right? Sometimes, and that's the work of an engineer sometimes. Some business requirements come and you have to figure it out. So with the specific constraints that they had, they wrote what is called a caster registry, and they open sourced it.
Oh,
Um, yeah, so and they only solved this problem for Java. They're a big Java shop, but they created a registry where these casting rules between one schema to the other can be stored, and then at runtime, your program can extract them and leverage them to cast the schemas from a version one to a version two.
okay. So you're
Yeah,
making a query on their server saying, "I've got a version
yeah,
1 and I want to read a version 4. Can you give me a bunch of rules?" That's pretty
exactly.
cool.
That's
That's pretty
exactly
cool.
right.
Yeah.
Yeah,
Okay.
it's it's extremely cool. I think they solved the problem in a very clever way. It does come with its own drawbacks, right? One, it is a more complex manner of maintaining your data because you have to write casting rules for every version of the data that you put out there, right?
Yeah.
Because you want to transfer them.
Yeah.
Not only that, these casters are not multi-language compatible, right? If you unless you define kind of like uh, a way to transcribe, rules onto code for many different languages,
Yeah.
you'll have an issue with that. So for them, they wrote a registry that stores rules for Java objects, right?
Yeah.
But if you're thinking, multi-language support, it's going to take you more time, right? And it's going to take more effort, right?
Yeah.
It
Yeah.
is it is a clever solution to a complex problem, but not every company will find this problem.
Yeah.
Yeah.
You have to be in that particular. I mean, you're obviously going to get to that world in the crazy life of financial products where you can keep your
Hmm.
data around for 40 years and the rules of it are arbitrarily changed by governments many times.
Exactly.
Yeah. Yeah. Yeah.
Exactly.
Okay. So don't start solving that problem until you have it is always good advice in software.
Exactly. Yeah, you got it.
There was one more thing I wanted to pick you up on that you mentioned, which surprised me.
Yeah.
You wouldn't recommend storing your master copy of the schemas in Schema registry.
Yeah. Yeah, that's a big one that I've learned over time with working with many different customers.
Yeah,
Listen, I I work for Confluent, right? So I like Schema Registry quite a bit, and clearly I work with it a lot. I
yeah,
think it's a great product, but I think that there is a lot of value after seeing all of these companies to maintain your source of truth and your golden record of schema definitions away from a service that might require a custom exporting mechanism and maintaining them centrally on
mm,
and version on and the recent trend is GitOps on a GitOps manner in a Git repository where you can do with that data as you'd like, right? You can put certain build rules so that whenever evolution happens, there is checks with schema registry. And I still think schema registry plays a big part here, right? Like if I want to evolve a schema in my GitHub, repo, I wouldn't want to just allow you to put a PR and then merge it with no issues, right? Like you'd have built constraints that
Yeah.
say, hey, this new version needs to be compatible to the old version. Make a call to schema registry to make sure that these compatibility rules are being followed, right?
Yeah.
And whenever it actually gets committed onto the main branch, right, you'd want to make sure that as that merge is happening, that there is a check that says, hey, I know that we said that it was good on the PR, but let's make sure that on the whole, on the new build, that the main branch is still, buildable and can
Against
publish,
that
right?
version. And would you then, as part of your CI hook, push that schema up to schema registry?
Yeah, I would.
Yeah.
Yeah,
Yeah.
on every main branch merge for sure.
Do you know what it makes me think? It's almost like you're keeping your schemas in Git for compile time and in schema registry for runtime.
Yeah, that's a very good way to put it.
Mm.
It's not only that, right? Like sometimes, and you could get this from schema registry too, but it's another tool that developers can leverage to say, hey, I have a bunch of objects that I need to resolve for my data needs. I can just pull down this Git uh, repo and then utilize something like the Avro CLI or the Proto CLI to render all of these objects for the language of my choice
Yeah.
in order for me to use them, right? So it allows you to have a nicer way to pull them, a nicer way to make them more publicly accessible, evolve them, right? And really, it allows you to be even more compatible with other discoverability tooling, right? Like today, data discoverability is a big point of emphasis because everybody's trying to get a data mesh, everybody's trying to get different business units talking to each other and making sure they can leverage data. Data discoverability is the number one problem in this equation, right? All the other stuff is hard. Don't get me wrong,
Yeah.
but even if you have all of this stuff set up to actually, stand up the concept of a data mesh within your company, discovering the data
Yeah.
and making it actually consumable easily for all of these other internal customers, call it, um, is the hardest part, in my opinion. And there's some tooling around there to make it easier. But with a centralized system for all of your schemas, not only can you export these things to schema registry, but if you have a third-party rule for data discovery, you could export them to that tool and then discover data in that manner. Yeah,
Yeah. Yeah. I could very easily see someone having a Git repository of all their Avro or protocol buffer schemas, and that repository including easy steps to generate your preferred language code, and maybe even a web front end that let you browse that history. So for part of that
definitely.
discovery story, right? Do you know of any existing tools to make this easy, or is it still undiscovered country?
Yeah, it's halfway there, right? Schema Registry has a nice Maven plugin to kind of like help you generate schema publishing, schema compatibility checks, or to a schema registry instance. Right, the interpretation onto objects is mostly done by the projects, right? Like Avro provides its own way of interpretation and generation. Um, Protobuf does its own way, so that's kind of provided by the projects. I would say kind of like in an intra-language way of ensuring that all these checks are being done and then the objects being generated. There is not one good single tool out there yet. So
Right.
most customers that I work with end up writing, regular batch scripts that are runtime, do a lot of these things and leverage the different tooling to kind of like bring it all inside a single ceiling.
Okay.
Yeah, so it's a young space. It's still evolving. A lot of tooling is yet to come, and that's just that's another aspect of the space that can improve.
It's a new open source project waiting to happen, right?
There you go. Yeah.
Cool.
Also, fun fact: you mentioned, hey, I can see having like your Avro schemas or your Protobuf schemas in a Git. I work with customers that have both in the
Oh,
same Git
really?
repository, and they have ways that to translate Avro schemas onto Protobuf and Protobuf schemas onto
Oh,
Avro,
oh God.
and they give their developers and they give their developers, choice, right? Like, hey, you want Avro, you can have it. You want Protobuf, you can have it. All you need to do is follow these rules to make sure that this is transferable onto the other format later on for others to use. Yeah.
Right.
Yeah.
Yep. Agreement is the hardest thing in computer science. I'm convinced.
Agreed.
Okay, well, this has been a fascinating tour. I think we don't normally do this, but I think I'm going to try and open this up to the audience because I bet people have more questions. So if you have a question for Abraham, send us a message. You'll find my contact details in the show notes or a link on our YouTube version of this podcast. And we might do a follow-up episode where we grill you with readers' questions. How does that sound?
I love that. Hey, that's what I do for a job nowadays, right? It's mostly
Okay.
I work with a lot of customers. They grill me with questions, and sometimes I'll be, hey, that's a really good question. I've never heard of that specific problem before, and I'll have to go back and research it. And sometimes I'll be able to tell you the answer off the cuff. So I think that'll be a really fun episode.
Okay, we might do a challenge episode. Thanks very much, Abraham.
Yeah. Thank you, Chris. I hope you have a great day.
You too. Catch you again. Thank you, Abraham. Now, hopefully, that's answered all of your burning data evolution questions. But if not, then hit us up. Send us some messages. Drop us a line, leave us a comment, and I will gladly pull Abraham back in for a follow-up episode. Quite fun to do a big Q&A episode. It's a hot topic, right? There's a lot to learn, there's a lot to share, so don't be shy. Let us know. In the meantime, as well as leaving us your further questions, we have further answers for you. If you look in the show notes, you'll find a link to that core financial talk that Abraham mentioned. And if you want an in-depth course about how to use Schema registry, there's one from our very own Danica Fine, and you'll find that on Confluent Developer, along with lots of other useful Kafka courses. So go and check it out at developer.confluent.io. And with that, it remains for me to thank Abraham Leal for joining us and you for listening. I've been your host, Chris Jenkins, and I will catch you next time.